Hello, and welcome to this quick take video covering the Vivado IP constraints flow. Here's an overview of what I will cover in this video. I will describe the constraints that an IP can deliver. There are some constraint files that are created for the IP during the flow, which I will also go over. I will cover the synthesized design checkpoint that is by default created for most IP. I will also discuss the order in which constraints are processed. This will include what constraints are used during the DCP creation, as well as what constraints are used when synthesizing the top-level design, which has IP DCPs present. The IP delivered in the Vivado design suite typically come with constraints that are split amongst a few files. This is because they need special processing or come from different sources. Typically, an IP delivers a core XDC file which contains any clock creation commands, as well as commands without clock dependencies. This file has the name of the IP customization and an extension of XDC. This file is processed before user constraints by default. Some IP also include another XDC file which contains any clock-dependent commands. Since top-level clocks can come from user constraints, any commands that need those clocks to be defined first are placed here. This file has the name of the IP customization with an _clocks. This file is processed after user constraints and other IP constraints by default. The _ooc.xdc file contains default top-level clock definitions for the IP. This file is only used in the creation of the synthesized design checkpoint file if the default flow is used. Since the IP is synthesized out of context of the top level and other IP that would provide the clocks, this file is needed to provide the clock definitions. Some IPs support a board flow. When creating a project, if a development board was picked, then there will be an additional tab during the customization of the IP, which allows the user to specify which connections on the board the IP connects to. This will result in an board.xdc file being created, which contains physical constraints. Some IP might have additional XDC files. This might be because they deliver constraints that are to be used only during synthesis or only during implementation. Here we have the wave generator example design loaded. Synthesis has been performed and the synthesized design has been opened. Going to the IP Sources tab and expanding the character FIFO, we see that a DCP has been created for this IP, which is the default. You can also see that structural netlists have been created for simulation. There's also a stub file which can be used with third-party synthesis tools to infer a black box for the IP. Expanding the synthesis group shows the non-encrypted files that the IP delivers for synthesis. Here we see three XDC files that this IP delivers: the char FIFO clocks.xdc, char FIFO XDC, and the char FIFO ooc.xdc. The _clock.xdc contains constraints which have a dependency to a clock which comes from the top level. Opening this file shows the clock ports being queried for clock objects, which the period property is used for a set max delay constraint. To see what order the constraints are processed in, we can use the report compile order command at the Tcl console. I am using the -constraints option to limit the output to be just constraints files. Let me expand the log a little so we can see more. Starting from the bottom, we see that there is a synthesis and implementation section for each design run. Here we see the three XDC files that are delivered by the character FIFO IP and the order in which they are processed. First is the ooc.xdc, which is always processed first for an IP when creating a DCP. Next is the core XDC, and coming last is the _clocks.xdc. Scrolling up, we see the sections for the clocking wizard IP. At the top of the report output, we see the section for the top-level synthesis. Here we see that the IP DCP are listed after the top-level constraints file. The DCP contains multiple XDC files, and the order of their processing is more complex than is currently shown in this report. I will cover this in more detail in a little bit. During the synthesis and implementation flow, some constraint files are automatically created by Vivado and used while processing IP. The first of these is the .xdc file. This file is used during the creation of the IP synthesis design checkpoint, which is created by default for most IP that are delivered with Vivado. This file contains commands to put a don't touch property on the top levels of the IP. This prevents the interface ports from being optimized away during synthesis. You will see this being read if you look at the log file for the IP design run. I will show you this later. The next file that can be created for IP is the .buffer.xdc file. This file is used when synthesizing the top-level design that has IP that a DCP has been created for. During synthesis of the top level, the IP is a black box, meaning that the logic is not visible to synthesis. This file contains commands to set the buffer type property to be none for any top-level port which connects directly to the IP. This prevents I/O buffer insertion. Some IP contain I/O buffer instantiations in their RTL, and this property will prevent an additional buffer being placed at the top level. Later, if an I/O buffer is needed, it will be inserted during implementation. The final file that can be created automatically during the flow for an IP is the in-context.xdc file. This file is used when synthesizing the top level with IP which has a DCP. The file contains clock creation commands for the IP which a clock originates. These clock objects are created on the boundary pins of the IP black box cell. This constraint file is created when the IP DCP was produced and is delivered inside the DCP. This file is not needed during implementation as the IP is linked and there is no longer a black box. Here's the WaveGen design again. To see where the .xdc file is used, we go to the Design Runs tab and select the char FIFO run. Going up to the Properties area and selecting the Log tab, we see the synthesis log for this run. Let's expand this and look for the .xdc file. We see it is read here in the log and later where it is processed. Now, let's go to the top-level synthesis log and expand that. Searching for the .buffer.xdc shows where it is read and where it is processed. Finally, let's look for the in-context.xdc files. We see that only the Clocking Wizard IP had a file created. This is because the Clocking Wizard IP creates clock objects that are needed during synthesis of the top level. The synthesized design checkpoint is a container file and consists of many files. The first is an edif netlist for the IP. Next is an _stub.v file, which is used during synthesis of the top-level RTL with the IP DCP for black box inference. There are 3 XDC files as well, grouped by the processing order they have. The _early is for constraints marked to be processed before the user constraints. The next, with no underscore extension, is for constraints marked with normal processing order. This is not used for IP. The _late XDC file is for constraints marked to be processed after the user constraint, such as constraints from the _clock.xdc file. Finally, there is the in-context.xdc file, which provides clock creation commands to be used during synthesis of the top-level RTL as explained previously.